Hello tubers, here we have some updates on the ista i1500. It has some changes made to the wind graph, and the reason those changes have come to light is because we were testing this 48 volt wind turbine with a 24 volt battery. However, the ampage that was used off of the 24 volt specs on the data sheet, and the voltage was used off of the 48 volt spec data sheet from Istabreeze. So what I've done is I've changed some of that data sheet settings from the 48 volt settings in the voltage only and left the ampage the same, and I've converted the 48 volt settings along with the existing 24 volt settings to be pair matched, and the results were very satisfying, to say the least. Now keep in mind, we are in low wind, very low wind, just it's 20 kilometers an hour, so we may get some gusts in the video, but the point is, this is the best overall wind curve for the Istabreeze i1500 24 volt only, but it's only through testing can I give this information to you. If you look, you can see that we're hitting around 115 watts, but this would always in 250 watts. In low wind, we're only in 25 kilometers per hour. So these results would never come to light before, because I had 48 volts steppings in with this wind curve. So now when I set them all down to initial 24 volt settings, these numbers have all changed. So in the end result, I was holding the turbine back by 50% by testing with it on the 48 volt settings. So understanding that, we now unleashed it to its full potential in low winds to get the maximum potential out of the turbine that we can. Here is the updated wind graph that I can give you. And we are only in rated winds, so you can take this and I'm not very good at editing, so just take this and pause it, and them are the numbers I used. They are in fact the same voltage settings from the spec data sheet from Istabreeze for the 24 volt Istabreeze i1500 turbine. Now again, I changed it from the 48 volt turbine because I don't personally believe there's a difference if you have either the 48 or the 24 volt Istabreeze turbine, because that is on the AC side, and it is, however, converted from the three-phase bridge rectifier on the DC side that goes into the charge controller. So for that reasons, you could use either one, but by pair matching this 24 volt ampage and the 24 volt voltage off the data sheet spec from Istabreeze, I have already made 50% increase in its efficiency or production. So understanding that, that is the wind curve I used. We started off with 1 on the ampage, and we moved, I went to 2 to 3, then to 5, then to 8, and so on all the way down. For those that want it, I'd be happy to put it in the information below. However, on the bottom, this was the one that was set with the 48 volts, and I converted it to the 48 volts, meaning the top voltage is 90. Now that's what's stated in the over circuit voltage for the turbine for a 24 volt. With that setting made and the ampage at 55 and the open circuit voltage at 90, those were the numbers from the data sheet for the 24 volt. Understanding that, we move forward, and in low winds there's 300 watts. Now that's only a 30 kilometer gust. Those numbers were not seen in this tests. Anything that was seen for the higher numbers was in fact with the highest wind I seen was 37 kilometers, and it only produced 600 watts. So by testing with the 24 volt settings with the 48 volt wind turbine, it has increased the performance by 50%, meaning 50% gain. And it's also tested in the lower winds to find this setting. So for them reasons, that wind graph will be the final wind graph, or the final results for the maximum production of this turbine in this findings. Now we're at 14 kilometers and I'm still creating 2 watts when I would otherwise with the higher voltage settings not get that. So understanding this is for the 24 volt 1500 turbine only. If you go to the 48 volt, then yes, those settings would have to be changed with both the ampage and the voltage. However, this is for the settings for the 24 volt IstaBreeze 1500 only. And the production harvest has a 50% gain by running with that. So this is the final test with that, understanding that we are in low wind, and at 14 kilometers I'm still making 2 watts. I realize it's not a lot, but it is still productive just the same. So making those changes for a 24 volt, both on the ampage and the voltage, has increased this by 50% because the voltage was in fact set to meet the 48 volt turbine. So by putting them together with both 24 volts, they now have harvested 50% gain. Now we're at 16 kilometer winds and we're still creating, well, 0 now, but 2 watts. The point is, I am now gaining in the lower winds, and that was the goal. So we do have the IstaBreeze i2000 en route, and there is one further test we're going to do to conclude this, but as far as the wind curve goes, this is the best curve for the 1500 on 24 volt that I've used to date. Now, yes, it will unleash higher numbers, but I do need higher wind, and at 15 kilometers an hour right now, I'm still producing 2 watts I would otherwise not get with the higher voltage settings as prior to before in the other videos. Understanding that, when the only other tests that we can do on this, once we reach maximum potential in low wind harvest, is to put a 5-blade hub on there with 5 blades, and that'll be the next test that we will in fact do. Now, the wind on the wind graph up there is reading 19 kilometers, and inside the cabinet I've left that open to monitor it so that I can see when it does go into dump load, because this small amount of harvest or gain in low winds, which is 19 kilometers now, and it's still lollygagging around making small power, and then when you get a little higher gusts, as you can see, it's 2 watts. And yes, I know it's not very much, but I wouldn't have got this before, so this does come of interest to have the low wind gains I'm looking for. So that only stands to reason to say that when I get the higher gains, it's going to increase with it for the 50% increase on efficiency, which is what I was looking for. So moving forward, the battery bank is reading 26.9, and at 27.6 we can see the TriStar 60 is up there to engage dump load. But I had to turn one of the solar array strings off so we didn't go there and prematurely just make power and dump it into dump load. I also have the heat pump running, so in one string of the solar off, because it made that much of a difference in power for the low wind with the voltage change that I had to run the heat pump, turn off a string of the solar array so we didn't hit dump load in this low wind rating. Understanding that, we move forward, and I hope this helps, guys, but this is in fact the best wind curve for the IstaBreeze i1500 with the 24 volt battery bank. So understanding that, this is the final results and the last results. Stay tuned. We will have a further update on the 5-blade, because I believe the possibility exists to create even better performance on the low end. Now, yes, we will lose the higher end performance, but I'm looking for the low end gain. However, with that said, that's for another video, and that will be in the next testing of the IstaBreeze i1500, and this is the findings given up to date. So I hope this helps, guys. This is the latest findings of the IstaBreeze i1500 pair matched with the Midnight Classic 200 for the overall results to be spec data sheeted for the 24 volts, meaning 90 volts open circuit voltage and 55 amps. That was what was the settings used for the Classic. Hope this helps, guys. Until next time, keep testing. Thanks for watching.